So students, now let us consider different cases. I am writing in the note. So that is first one, if medium impedances are matched, that means eta 1 is equal to eta 2. Actually they are different mediums, but this ratio, for example root mu1 by epsilon 1 and this is mu 2 by epsilon 2, so they are eta 1 and eta 2 are equal, but medium types are different. Anyway, if two different mediums are there, but impedances are matched, that means eta 1 is equal to eta 2. So if medium impedances are matched, this is the meaning. Medium impedances are matched means, then that is if medium impedances are matched, that is eta 1 is equal to eta 2, then reflection coefficient is equal to eta 2 minus of eta 2 divided by eta 2 plus eta 2, because eta 2 minus eta 1 is nothing but eta 2 only, you get 0. So what is the definition of you got gamma 0? What is the definition of this? ER0 by EA0 is equal to 0. That implies ER0 is equal to 0. That means there is no reflected wave in medium 1. And in this case, 1 plus reflection coefficient is equal to transmission coefficient. That means gamma 0, so transmission coefficient is equal to 1. What is the definition of transmission coefficient? ET0 divided by EA0 is equal to 1. So ET0 is equal to EI0. Okay, ET0 is equal to EI0. Now, basically, if you find SWR is equal to 1 plus mod gamma divided by 1 minus mod gamma. That means 1 plus 0 divided by 1 minus 0. So SWR is equal to 1 actually. So dear students, here conclusion is for impedance matching, that means if medium impedance are matched, in this case you got reflection coefficient 0, that is nothing but reflected electric field will not be present, and SWR is equal to 1. Standing wave ratio 1 meaning is incident signal is equal to transmitted signal. That is the meaning. There is no standing wave in medium 1. So these are the results actually. Now in this case you see here there is no reflected wave in medium 1. In this case there is no reflected wave in medium 1. That means in medium 1 there is no reflected wave. That is one thing. Or otherwise, if there is no reflected wave, then there is no standing wave in medium 1. What is the meaning of standing wave? Wave is in standing means there is no transmitted wave. That is the meaning. Standing wave means not a traveling wave. Standing wave means not a traveling wave. So dear students, in this case there is no reflected wave because ER0 is equal to 0. There is no reflected wave in medium 1, or otherwise there is no standing wave in medium 1. Actually, there is no standing wave in medium 1 means there is a complete traveling wave in medium 1 also. There is a complete traveling wave in medium 2 also. That is the meaning. So there is no standing wave in medium 1 means there is a complete there is a complete traveling wave in medium 1 and there is a complete traveling wave in medium 2. So there is no reflection in this case. This is what required, but this is not in our hands. Mediums decide that. Whenever once if you leave the electromagnetic wave into the air medium, then it is not in our hands. It can go anywhere, it can cross any medium, it can be reflected by some mediums, it can be transmitted. So that will be not in our hands. So second case, student, if medium 2 is a perfect conductor, then sigma 2 is equal to infinity, then eta 2 is equal to j omega mu divided by sigma plus j omega epsilon is the actually what do you say impedance equation for 2 for second medium suffix 2 suffix 2 suffix 2 comes then if sigma 2 is infinity, then j omega mu 2 divided by infinity plus j omega epsilon 2, you get 0 actually. If medium 2 is perfect conductor, then eta 2 is equal to 0 you get. Okay. Now in this case, reflection coefficient is equal to eta 2 minus eta 1. Eta 2 plus eta 1 is general formula. So substitute 0. Now you get minus 1. So what is the meaning of gamma is equal to minus 1? Gamma is ER0 by EA0 minus 1. That means ER0 is equal to minus of EA0. So in this case, reflected wave is exactly equal to the incident wave, and both are in opposite sign. Both have opposite sign. That means the meaning is whatever signal is incident onto the conductor surface, then completely it is reflected back. Minus meaning is reflected back completely. So in this case, there is no traveling. There will be no traveling wave in medium 2 because you get transmission coefficient 0. You can calculate if you want. Transmission coefficient, no, you can calculate. 1 plus reflection coefficient is equal to transmission coefficient. That implies 1 plus reflection coefficient is here minus 1. So, and you get transmission coefficient 0. That means transmission coefficient 0 means transmission coefficient definition is ET 0 by A 0, that is equal to 0, implies there is no transmitted wave. So in medium 2 there is no transmitted wave. Whatever wave is incident, that is completely reflected, so that in medium 1 there is a complete standing wave. Complete standing wave means there is no traveling wave at all in the medium 1 because medium 2 is completely reflecting that one. Now in this case, if you find the SWR, that is equal to 1 plus mod gamma divided by 1 minus mod gamma, that is 1 plus 1 divided by 1 minus 1. So that is actually 2 by 0, that is infinity. So SWR infinity means whatever signal is incident on medium 2 completely reflected back. So 100% standing wave is there in medium 1. That means 100% standing wave in medium 1 is present, means there is no traveling wave at all in medium 1. That is the meaning. So dear students, here you have seen here in medium 1, total E bar is, total E bar in medium 1 was, this is the equation, if you remember I wrote earlier, A0 into cos of omega t minus beta 1 z Ax plus ER0 cos of omega t plus beta 1 z Ax. This is general equation. Okay. If eta 2 0, that means that medium 2 is perfect conductor. That is medium 2 is perfect conductor. Then what will happen? ER0 becomes minus EA0. So ER0 becomes minus EA0. That is equal to EA0 cos of omega t minus beta 1 z AX cap. ER0 is equal to minus EA0 cos of omega t plus beta 1 into z AX. So ultimately, if you pull out EA0, then you get cos of omega t minus beta 1 z minus cos omega t plus beta 1 z. So this one is AX cap. So what is this actually? You get 2 times sin omega t and sin beta 1 z you get. So you get 2 EA0 sin omega t sin beta 1 z. Okay. So this is the total electric field equation in medium 1 whenever second medium is perfect conductor. Now if you want to draw this equation at particular time it is observed. So let us observe this equation at t is equal to t by 4 time we are observing the shape of this equation. Let at t is equal to t by 4. Let t at t is equal to t by 4. What happens? Omega t is equal to omega is 2 pi by capital T and t is t by 4, and ultimately you get pi by 2. So in this case what happens? Sin omega t becomes sin, this is pi by 2, that is 1 actually. Now electric field E1 bar, of course I will write magnitude because direction is AX cap. Now we want to draw the magnitude. So at t is equal to t by 4 time we are writing is equal to 2 times EA0. This sin omega t becomes 1. Only this is there. So sin beta 1 into z. So this 2 EA0 sin beta 1 is 2 pi by lambda 1 into z. So for example, at z is equal to 0, this value, I will write modulus of E1. Why to write all the things? Modulus of E1 is equal to 2 EA0, then sin 0 you get, so that becomes 0. Next, at z is equal to lambda by 4 I will write. Then modulus of E1 is equal to 2 EA0, 2 EA0 sin, at for medium 1 no, we take lambda 1. Okay, lambda 2 means for medium 2 wavelength. Now sin 2 pi by lambda 1, here z is equal to lambda 1 by 4. So lambda 1 cancel, pi by 2 you get, sin pi by 2 is 1, 2 EA0 you get. Similarly, at z is equal to lambda 1 divided by 2, then modulus of E1 is equal to 2 EA0 sin 2 pi by lambda 1, z is equal to lambda 1 divided by 2. This cancel, 2 to cancel, sin pi is 0 actually. So once again, at z is equal to so z is equal to 3 times, so this is 0, lambda 1 by 4, This is 2 times lambda 1 by 4, that means this one, 3 times lambda 1 by 4. You will get E1 is equal to 2 EA0 sine 2 pi by lambda 1, and that is 3 times lambda 1 by 4. Lambda 1 cancel. This you get pi by 2, 3 pi by 2 you get. So 3 pi by 2 means sine 180 plus 90. That means that is third quadrant. Here you will get third quadrant na, minus sine pi by 2. So minus 2 times EA0 you will get. Okay. Now at Z is equal to 4 lambda by 4. Actually what we are doing, 0 times lambda 1 by 4, 1 times lambda 1 by 4, this is 2 times lambda 1 by 4, and this is 3 times lambda 1 by 4. 4 times lambda 1 by 4 means simply that is lambda 1. So we are calculating systematically 2 EA0 sine 2 pi by lambda 1, and this one is lambda 1. So that becomes sine 2 pi is 0. If you draw this situation is like this. This is Z is equal to 0, Z greater than 0, medium 2. Here it is a perfect conductor is there for this sigma to infinity, and eta 2 is equal to 0. Now this is Z less than 0. So when EM wave hits here, it is reflected back. Now the total electric field equation is sine signal. So sine signal means here it is like this. It is like this, dear friends. Okay, maintain the symmetry. Maintain the symmetry. Okay, anyway. Now here, this is the center. This electric field is 0 here. This value of electric field is actually 2 EA0, and this value of electric field is minus 2 EA0. This is 0 electric field. Okay, I will write here minus 2 EA0. This is 2 EA0. Anyway, I have written here, doesn't matter. So here this is the distance actually. If you see here, and this one, okay, this will be actually lambda. Now of course lambda 1, it has become distance period. Now distance axis, this is lambda 1 distance. Of course this one is lambda 1 by 2. You can see here, whenever Z is equal to 0, this value is 0 here. Then whenever Z is equal to lambda 1 by 4, that means this one, that is highest value 2EA0. Now whenever Z is equal to lambda 1 by 2, that means this one, and again value becomes 0. Whenever 3 lambda 1 by 4, this is here minus 2I0. I will do one thing, students, here 2EI0 I will write here. I will remove this here. I will write little. So here electric field I have taken minus 2EI0, it is here 0 electric field, here 2EI0. This is a medium to perfect conductor. This is infinity. For this eta 2 is equal to 0 we got. Okay. Now it is the total electric field equation in the medium 1. This is medium 1. Anyway, these things are not asked in the examination, just for the sake of mathematics we are doing. Anyway, now one note we will write here, that is third point. What is that note actually? Here you have seen that if mod gamma 0, then SWR is equal to 1 you got. If mod gamma is equal to 1, then SWR is equal to, what do you say, infinity. That means what is the range of mod gamma? Mod gamma range is actually 0 less than or equal to mod gamma less than or equal to 1. Okay. What is the range of SWR? The least value of SWR is 1. The highest value of SWR is infinity. Mod gamma 0, that means SWR is 1. In that case, there is no reflected wave in the medium 1. Mod gamma is equal to 1, or otherwise SWR is equal to infinity. That means there is a complete reflected wave in medium 1. So that is the meaning. For other cases, if mod gamma value is in between 0 and 1, then SWR will be in between 1 and infinity. So this range, in examination you get what is the range of mod gamma? This is answer. What is the range of SWR? This is the answer, students. So this range you have to remember. And here, what is the meaning of this one? No standing wave. No standing wave in medium 1. I will write this that side. Let it be here. No place actually. Okay, student. So this range you have to remember. So here I am writing you can see this one. Whenever this is 0 and then this is 1, SWR infinity. So if mod gamma 0 or otherwise SWR 1, no standing wave in medium 1. If this is this, then complete standing wave in medium 1. If values are in between, then a little bit standing wave, little bit traveling wave. So we say partial, that means little bit, partial standing wave in medium 1. This is the meaning, students. Now, actually I wrote note, that is the first point. In the note, second point, SWR in decibels I want. See, I am talking of network theory. In the network theory, if you take power ratio, power 2 divided by power 1, if you want this power ratio in decibels, you will take 10 log 10 power 2 divided by power 1. Actually, what is the power ratio? Power ratio is nothing but voltage squares ratio. Now, if voltage squares ratio is there, for both of them I am taking R reference voltage, reference resistance same I am taking. So V2 square by R, V1 square by R are gone. Now this whole square is there. Otherwise I will take I2 square R, I1 square R. Then for currents as well as for voltages, you get 20 log 10 V2 by V1. So that means if power ratio is taken for decibels, 10 log is taken. For voltage ratio or otherwise for current ratio, 20 log is taken. Similarly, in electromagnetic theory also, if power ratio is there, for decibels we take 10. If electric field ratio is there, then we have to take 20 log for the decibel calculation. So here, if you see carefully, what is SWR? SWR is equal to electric field ratio, that is actually electric field maximum electric field ratio. That means if you want SWR in decibels, you have to take 20 log because it is electric field ratio. So in network theory, for power ratio, you have to take 10 log for decibels. Voltage ratio and current ratio 20 log you have to take. Similarly in EM theory also, for power ratio we will take 10 log. For electric field ratio and for magnetic field ratio we have to take 20 log actually. So in the question, if you want to calculate this SWR in the decibels, then what to do? SWR in decibels, if you want to calculate, then you have to take 20 log SWR. Okay. Then if you want reflection coefficient also in decibels, then once again you have to take 20 log only. Why? Why, dear students? Because reflection coefficient is defined as reflected electric field by incident electric field. So that is also ratio of electric fields only. That is why 20 log you have to take. So if anybody asks you, for example, gamma is equal to eta 2 minus eta 1 divided by eta 2 plus eta 1, then you take mod of that. Then if you want to calculate in decibels, you have to take 20 log. Okay. Now next point, in the note third point. Here one calculation is there called return loss, RL it is called as. So return loss, RL, is defined as the ratio of incident power and reflected power. Incident power and reflected power. Okay. So return loss, RL, is defined as incident power divided by reflected power. So incident power is half into EI0 square. I will write, okay, half into EI0 square divided by eta 1, that is actually density. Density by density if we take, then power ratio we get. So reflected power is half into ER0 square divided by eta 1, because incident and reflected both are in medium 1. So eta 1 is coming. That is equal to here EI square ER square. That is nothing but modulus of ER0 modulus of EI0 whole square. What is this? Modulus of gamma E square. Okay. And I can write this as a mod gamma E power minus 2. So return loss is defined as ratio of incident power and reflected power that you get modulus of gamma E power minus 2. And if you want return loss in decibels, I told you it is a power ratio, so you have to take 10 log. So 10 log 10 RL, that is nothing but 10 log 10. What is RL here? Mod gamma E power minus 2. So that is nothing but minus 20 log 10 modulus of gamma E. So this is the return loss in decibels. Actually What is the meaning of return loss? In name itself it is there. Because of return power, that means reflected power, how much loss is there? That loss is always compared with incident only, because from incident only reflected is generated. Return loss meaning is because of reflected signal, how much loss is there? Actually, engineers don't want reflected signal, but that is not in our hand. That is decided by the medium. So return loss decides how much is reflected uh, compared to incident. That is actually loss, because we don't want that one. So these are all some formulas, dear friends. You have to remember them. So students, now let us solve the questions. Chapter 3. This is question number 8, regular workbook. For GATE students, it is question number 6 actually. Anyway, don't bother about question numbers. I am writing the questions. So this is the MSQ question, multiple answers. I am changing the question. Which one of the following statements are correct for a plane wave with h bar is equal to 0.5 e power minus 0.1 x cos of 10 power 60 minus 2x az cap ampere per meter. Okay. Now if you see carefully, this h bar equation is nothing but this is hi0 e power minus alpha x cos of omega t minus beta x here az cap. So try to get the information from this one. So it is given hi0 is equal to 0.5. Alpha is present means loss is present. Then beside time 10 power 6 is there, that is omega. Beside distance 2 is there, that is beta. And wave is traveling in plus x direction. I told you equate this to 0. So 10 power 6t minus 2x 0. Then x is equal to 10 power 6t divided by 2. It is positive. So ultimately wave is traveling in plus x direction. So wave is traveling in plus x direction. Now let us see the options one by one. Which of the following correct? Let us see. First one, the wave frequency is it is given the wave frequency is 10 power 6 radian per second. Actually students, frequency given means that is cycles per second, but it is given radian per second, that should be omega. So that is correct actually. It is given omega is 10 power 6 radian per second. Now he has given wavelength is equal to 3.14 meter he has given. Now let us calculate that. So if beta is given, then wavelength is equal to, actually beta is equal to 2 pi by lambda formula. So lambda is equal to 2 pi by beta. So 2 pi divided by beta is 2 is given. So that is nothing but pi. That means that is 3.14. So that is also correct actually. In statement C, the wave travels along plus x direction. That is also correct. The wave travels in plus x direction. So this is also correct. Next option D is given. The wave is polarized in z direction. The wave is polarized in z direction. It is given. Students, we are going to study this polarization. Polarization means direction of electric field. Polarization means direction of electric field. Anyway, here a magnetic field in z direction, definitely electric field will not be in z direction. So this is the wrong answer. We are going to study, student, now. Polarization means direction of electric field. If you want electric field direction, I told you E, H, P are in the sequence. So AH cross AP, EHP are in the sequence. Magnetic field is in Z direction. Then power flow is in X direction. So you get electric field in Y direction. AZ cross AX is AY. So electric field direction is called polarization. So wave is polarized in Y direction, but it is given Z direction. That is wrong answer. Now, next statement. The velocity of the wave Vp is equal to 5 into 10 to the power 5 meter per second is given. Let us see that velocity is equal to omega by beta. Here omega is 10 power 6 given, beta is 2, that means that is 5 into 10 to the power 5. So this is also correct. Next, in F statement it is given the propagation constant is it is given that gamma is equal to 0.1 plus j2. Now gamma is nothing but alpha plus j beta. Gamma is equal to, here alpha is 0.1, beta is 2, so 0.1 plus j2. So this is also correct. Now next question I am writing, maybe in gate book this is not there, but you have to solve this. Next question. The electric field component, the electric field component of a wave in free space is given by E bar is equal to 50 sin 10 power 70 plus kz j cap volt per meter. Which of the following is the correct inference that can be drawn from this expression? Okay, I mean it is asked which of the following is correct. Then in option B, it is given the wavelength is 188.5 meter. So that is correct actually. If you see in option A, the wave propagation along y axis. No, the wave propagation in minus z direction. So that is wrong. In option C, the wave number beta is 0.33. It is given wave number k. Here beta is k actually. So some books in place of beta they write k. So beta is called phase shift constant. That is also called as wave number. So let us calculate one by one. Wavelength. How you calculate wavelength? First you see here. It is medium is free space, and omega is given. Omega is 10 to the power 7. It is free space. Dear student, we have seen for free space wavelength lambda naught is equal to c by f. That means 3 into 10 to the power 8 light velocity. F is 10 power 7 divided by 2 pi. So this one is 30 into 2 pi. You get so that is 60 pi. So 60 into 3.14 approximately. 6 into 3, that is 180. Then 6 into 14, approximately this is correct. So this is the correct answer. B is the correct answer. Now wave number k is asked in option C. No, it is given that beta or otherwise k is given as 0.33 radian per meter. Now let us calculate. I told you one important formula, that phase velocity is equal to omega by beta is equal to c by root mu or epsilon r. It is free space now given. So omega is given how much here? 10 power 7. Beta is not given. And for free space c is 3 into 10 power 8. For free space mu r is equal to 1, epsilon is equal to 1. From this you send this side, you have to send this side. So beta is equal to 10 to the power 7 divided by 3 into 10 to the power 8. So 1 by 3 is approximately, it seems 0.33 something, and it goes there 10 to the power minus 1. So that is 0.033 radian per second. That is nothing but k, but he has given 0.33. So this is the wrong answer. The wave attenuates when it travels. In option D it is given. That is also wrong, because there is no alpha here. So wave does not attenuate. Okay. Now next question. An EM wave in free space has electric field x comma t is equal to 25 sine of omega t plus 4x ay cap volt per meter. Now here so many things are given. Find h of x comma t is asked. So dear students, if electric field equation is having 25 sine omega t plus 4x ay cap is there. Now in magnetic field equation, then it is ei0, but in magnetic field equation you will have hi0. So h of x comma t, you will have hi0. In electric field equation is sine is there, here also sine. If cos is there in electric field equation, here also cos. So if sine is there, here also sine. Frequency does not change omega t. Actually, students, in electric field as well as magnetic field, frequency information, beta information, wave propagation direction, everything will be same as it is. So sine omega t plus 4x, only two things are going to change. Electric field magnitude will be A0, magnetic field magnitude will be HI0. Electric field direction is here AY cap, magnetic field direction is AH cap. You have to find that one. So here you know that E, H, P, they are in the sequence actually. Now AH cap is equal to AP cross AE. Now power flow direction is minus x direction. So power flows in negative x direction. Electric field is in y direction. That means minus of ax cross ay is minus az. So magnetic field direction is minus az. This one you got. Now hi0 na. This medium is free space. For free space ei0 divided by hi0 is equal to eta naught. From this hi0 is equal to ei0 divided by eta naught. So ei0 is 25, eta naught is 125. So ultimately h of x comma t is equal to 25 divided by 120 pi and sine of omega t plus 4x. Magnetic field direction is minus az. So this is the magnetic field equation. Okay. Now here next one is you have to find frequency, propagation direction. So tell me, here wave is propagating in which direction? So wave is propagating in minus x direction. Okay. Next, what is the frequency? What is the wavelength? It is asked. I already told you. So this is a free space. It is given, and in this beta is 4. It is given. I already told you, students, this phase velocity is equal to omega by beta is equal to c by root mu or epsilon r. This formula is important, I told you. So now omega is required, beta is 4, and c is 3 into 10 to the power 8. For free space, na, mu r is 1, epsilon r is 1. That means omega is equal to, so this is 12. 12 means 1.2 into 10 power 9 hertz. That is 1.2 gigahertz is the no student, radian per second. This is, it is omega, no, it is not hertz. So this much this many radian per second. Now lambda is also asked, wavelength is asked. So you have to find wavelength. Wavelength is equal to 2 pi by beta. Beta is equal to 2 pi by lambda, because wavelength for free space is lambda naught is equal to c by f. That is also formula. But lambda is equal to 2 pi by beta is also formula. Beta is given, so you can find that 2 pi by 4, that is nothing but pi by 2 meter. Okay, this is the answer. Have you seen, dear students? If you study the theory thoroughly and if you remember formulas, these questions are very easy to solve. Actually, electromagnetic theory is very simple subject compared to other subjects, because students do not know what to remember. So क्या याद रखना है, बच्चों लोगों को मालूम नहीं है. मैं हर चीज बॉक्स में रखा हुआ है, जो ऑब्जर्व करना है उसको भी बता दिया मैंने. आप केयरफुली ऑब्जर्व करेंगे, सो हर क्वेश्चन सॉल्व हो जाएगा. ठीक है. So students, now let us see this question. The electric field of a plane wave is given by, this is the electric field equation. Determine the magnetic field equation. Given mu is equal to mu naught. Did you observe? Mu r is 1, but epsilon r value is not given. So don't take epsilon r is equal to 1. I explained you in the theory. So if epsilon r is not given, definitely in that question omega beta will be given. So you can see here, beside time omega, beside distance beta are given. So from that you will be calculating epsilon r. So here you know that phase velocity is equal to omega by beta. Beside time omega is there, beside distance beta is there. So this is the what do you say, from this 1 minute, this is equal to c by root mu r epsilon r, one formula I told you. Now if you substitute omega here 10 to the power 9 and beta value 30, and this is 3 into 10 to the power 9, this c, and root of mu r is given 1 and epsilon r is required for you. So now here this one 10 to the power root epsilon r cross multiply. So 3 into 30 into 10 to the power 8 divided by 10 power 9. Ultimately, you get 9 root epsilon r is equal to 9 you get. Okay. Now, you want h bar equation. So, electric field is equal to 10 cos 10 power 90 plus 30 z ay cap. So, h bar is equal to, this is ei0 and hi0 cos of omega t, and actually I told you in electric field cos term, in magnetic field cos term, both will be same, and 30 z. So this is ah cap. Okay. Now here ei0 divided by Hi0 is equal to modulus of eta formula. Now that modulus of eta is equal to, here alpha is not there. Alpha is not there means sigma 0. If sigma is 0, it is eta naught root mu r by epsilon r. You can see, and you can see the notes. You will get that it is a dielectric medium, but alpha is not there means it is lossless dielectric. So anyway, now Hi0 means Ei0 divided by eta naught means 120 pi, root of mu r is 1, and divided by epsilon r. So Ei0 is 10 actually, so 120 pi 1 by root mu root epsilon r, it goes to numerator, that is 9 actually. Okay, 90 by 120 pi, this gone, so you get 3 by 4 pi you get. Okay, this is gone 3 4 times, so this is that one. Now EHP in the sequence. Okay, so many times we are writing this EHP in the sequence. So from this, magnetic field direction is equal to power flow direction cross electric field direction. You can see here, power is going in, wave is going in minus z direction, so power flow also is in minus z direction. Electric field direction is y direction, ay cap. So that is minus of this one is minus ax. Ultimately you get plus ax. So now what is magnetic field equation? H bar is equal to, Hi0 is 3 by 4 pi, then cos of 10 to the power 9t plus 30 z a x cap. Okay. Next question. The electric field vector E bar of a wave in free space is E bar is equal to A into cos of omega t minus z by c, okay, into ay cap. Its magnitude vector h bar is given by its magnetic vector, then h bar is given by. All are similar questions, students. All are similar questions. Okay, anyway, now let us solve this one. H bar is equal to, if this is Ei0 na, then here we get Hi0. I told you here cos term is there, sine term is there, exponential term is there, whatever term is there, it comes as it is here. So here cos term is there, cos of omega t minus z by c actually, right? This one is the ay cap is actually, this is electric field unit vector. Here you must get ah cap. Okay. Now this one is free space. For free space, Ei0 divided by Hi0 is equal to, in the options he is talking of root mu naught epsilon naught. So that is equal to eta naught. So eta naught is nothing but root mu naught divided by epsilon, because in answer sheet is given like that. So from this Hi0 is equal to, and that Ei0 divided by root mu naught by epsilon naught. So Hi0 is equal to Ei0 root epsilon naught by mu naught. And as usual, AH cap is equal to A here na, in previous we have written H cap is equal to AP cross AE. Now in this you see minus Z is there, that means power flow direction is plus Z direction, electric field direction is AY cap, So that is nothing but Az cross Ay is minus Ax cap. Now magnetic field vector is equal to this one. Hi0 is Ea0, Ea0 is A. So A root epsilon naught by mu naught, and this one cos of omega t minus z by c, and Ah cap is minus Ax. Okay, but if you see option A, B, C, D, this answer is not there in A, not there in B, and in C option, actually in C option, J is there, but this is there, but J is there, extra, that is. Same is there in C option, J came. So here J is not there, no? That means that is not the answer. So actually this question is very simple question, but that fellow tested you whether you know one concept or not. That is phasor concept. Already you know that, no, student. I told you. For example, cos omega t. Write that in terms of sine. That is nothing but sine omega t plus 90, or otherwise sine 90 plus omega t. So this is second quadrant. Then sine 90 plus omega t is cos omega t. Now I was telling you that 90 degrees is written as a j. So I told you j is equal to e power j pi by 2. That is nothing but e power j 90. 90 degrees phase is written as j, minus 90 degrees phase is written as a minus j, dear students. So this one in phasor form, this is simply written as j, 90 degrees is j sine omega t. That means cos omega t is written as j sine omega t in phasor form. So here cos is there, no? That is written as j sine. That is the trick in this question. So a root epsilon naught by mu naught. This cos is written as a j sine omega t minus z by c, and minus Ax cap. In option D it is there. In option D it is given j came here, minus came here, a root epsilon mu naught, sine term was there, omega t z by Ax cap. In option D it is there. So answer is D for this. Okay. Now next question. The electric field intensity of a uniform plane wave in air medium. So in air medium, I'm not writing a total question. So E bar is equal to 20 e power minus j5z Ax cap minus 25 e power minus j5 z Ay cap is given. Find Hx and Hy components of H bar. Okay. Now beside Ax cap, whatever is there, no, this one, that is called X component. So first case 1, let us take electric field has only what do you say, X component, then 20 e power minus j5z Ax cap. Because of this, what component of magnetic field is produced? So let us say this is E1. E1 means first component. Then because of this H1 bar, here EA0 is there, na? Here we have to write HA0. I told you here in exponential is there, you write exponential. Cos is there, cos you write. Sine is there, sine you write, like that. So e power minus j5z. Here electric field direction, here magnetic field direction comes. So he has given air medium. For air medium, EA0 divided by Hi0 is equal to, in options he has given 120 pi terms. This is eta naught. Eta naught is 120 pi. From this you want Hi0. So Hi0 is equal to Ei0 by 120 pi. Ei0 is 20. So 20 by 120 pi actually. Now what is AH cap? AH cap is equal to AP cross AE, because E, HP are in the sequence. If you want, I will write here that electric field, magnetic field and power are in the sequence. So AH cap is equal to AP cross AE. I am writing so many times so that it feeds into your mind. So AH cap is equal to power flow direction. In exponential minus Z is there. That means wave is traveling in plus Z direction. What is electric field direction here? AX. That is nothing but AZ cross AY is what, student? AZ cross AX is what? That is AY. Now can you write this equation? H1 bar is equal to that is 20 divided by this one, Hi0, 20 divided by 120 pi e power minus of J5Z. This is AY. So this is simply called as beside AY cap whatever is there, no, that is called HY into AY. In the first class I told you, beside AY unit vector whatever component is there, that is Y component of H vector. So HY AY. So now HY is this one. He is asked now what is HY? HY is this one. Next you take electric field second component. E2 is equal to 25 e power minus J5Z. I am taking minus here. So minus AY. Here also this is EA0. Now H bar due to this is equal to here EA0, here HI0. E power minus J5Z and AH cap. Now EA0 divided by Hi0 is equal to 120 pi. So Hi0 is equal to EA0 by 120 pi. EA0 is 25 divided by 120 pi, and AH cap is equal to AP. AH cap is equal to AP cross AE. So power flow is AZ and the electric field is minus AY. AZ cross AY is what actually? AZ cross AY is minus AX. That is AX cap. Okay. Now let us write this equation. H2 bar is equal to Hi0 is 25 divided by 120 pi. Then e power minus of J5 Z. AH cap is AX cap. That is nothing but beside AX cap whatever is there, that is called HX AX, and HX is nothing but this one. So have you seen electric field maybe Y or X component? No, electric field plus minus Y component generates X component. If electric field has X component, then it has to generate magnetic field Y component. Anyway, now total H bar is equal to this plus this one. Superposition principle. Electric field has one component, because of that magnetic field produced this component. Electric field has this component, because of that magnetic field produced component is this one. Total magnetic field is sum of them, like that. Okay, option C is correct for this. Option C. So students, you see this question. The x directed electric field Ex, that means electric field x component, having sinusoidal time variation e power j omega t and space variation in z direction. That means he is saying it is a function of time and it is propagating in z direction, he is saying. Satisfies this equation, and this one under source free condition. Source free condition means rho v is equal to 0. Already we have derived them by taking rho v 0 only. In a lossless medium, What is the solution representing wave propagation in plus z direction? Dear student, whatever might be the story here, for wave propagating in z direction, the equation should be like this. Electric field x component should be ei0 e power minus j beta z, it should be for wave traveling in plus z direction. If you actually j also should be there, minus also should be there for wave traveling in plus z direction, whatever might be the solution. So you see this option is wrong, because if j is not there na, then that is attenuation that represents. This option is also wrong. Then only two options are there. Here plus j is there, means that is the wave traveling in minus z direction. Here it is the answer. In place of k na, in place of beta na, k is given. I told you already, beta is also represented in some books as a k. Beta has two names, phase shift constant or otherwise wave number. So this is the answer. Whatever might be the case, e power minus j beta z should be there for wave traveling in z direction. Because if you take this, then only you get cos of omega t minus kz form. Then you equate this to 0, omega t minus kz. Then only you get k positive. Then only wave travels in plus z direction. Okay. Now, another question. In a certain lossy medium, that means loss is present, an EM wave travels for a distance of 20 meter, where its amplitude decays to 1 by E. So, first of all, you see electric field equation is equal to EA0 e power minus alpha z cos of omega t minus beta z. It is like this. Now, at z distance, electric field magnitude is equal to EA0 into e power minus alpha z. Okay, dear students, it is given lossy medium means alpha should be present. When wave travels for a distance of 20 meters, where its amplitude decays to 1 by E times, that means at z is equal to 0, amplitude is EA0. He has given at z is equal to 20 meter magnitude. Magnitude means what, student? Amplitude or otherwise magnitude. He has given that EA0 into e power minus 1. But from this formula, if you see EA0 into e power minus alpha into z is equal to 20, what is, how you got this? From the formula. This is the formula. At z distance, what is the magnitude of electric field? EA0 into e power minus alpha z. You go and see in the notebook, I wrote that and I kept that in the box. Now, this fellow gave, when wave travels 20 meters, its amplitude decays to 1 by E times. So, decays to means initial value is EA0, decays to means 1 by E, he said. That means that much is remaining. So, that is e power minus 1. So, this is actually given in the question, given data, that is given data. Okay. Now, EA0 e power minus alpha 20 is equal to EA0 into e power minus 1. Compare both sides. Alpha 20 is equal to 1. That means alpha is equal to 1 by 20. Next, you continue. 1 by E times its initial value. That means initial electric field is EA0. Now it has become 1 by E times EA0. Decays to, English you see, decays to 1 by E times of its initial value means it remains that much. That is the meaning. वो रहेगा उतना. Decays to मतलब वो कम होके उतना बचेगा, वो है meaning उसका. If the phase shift for the same distance period is 30 degrees, then gamma of the medium. Actually, I already wrote distance phase is equal to beta into z, dear students. It is formula. Now, for z is equal to 20 meter distance phase beta z is equal to distance phase beta z is equal to beta 20. So that is this is the formula. Actually, from the formula we wrote. Now in the question he is saying if the phase shift for the same period is 30 degrees, that means for same distance the phase shift is 30 degrees he has given. That means 30 degrees means pi by 6. It is given data. It is given in the question. Now from this beta is equal to pi by 120. Pi by 120. Now gamma is required, that is alpha plus j beta. So alpha is 1 by 20 plus j beta is pi by 120. So what is the option? Option is B. Now next question is a plane wave of 10 gigahertz is incident normally on a dielectric plate of 3 mm thickness. If the phase shift on transmission through the sheet is 90 degrees, then the dielectric constant, that means epsilon r, student, is, what is dielectric constant? That is the, see, the plane wave of frequency is given 10 gigahertz. Okay, is incident normally on a dielectric plate of 3 mm. Actually, what he is saying, this is a EM wave is incident on a dielectric plate. Some plate is there like this, some thickness. So this is of 3 mm. Okay, it is dielectric. Dielectric means it will have epsilon r. That's what we have to calculate. If the phase shift on transmission through the sheet, this is dielectric sheet actually. If EM wave travels through this sheet, then it experiences total phase shift 90 degrees. That means this is Z you take. So he has given for Z is equal to 3 mm. It is given distance phase, that is beta Z is pi by 2 when Z goes 3 mm. That is what given. Now what is required? Epsilon r is required. Okay. So beta into, for how much distance he has given that distance phase. See dear students, don't confuse. Whenever that fellow says when wave travels for 3 mm distance, the phase shift is 90 degrees means that is distance phase. So beta into Z is 3 mm, 3 into 10 power minus 3 is equal to, as given, pi by 2. So beta is equal to, from this directly you can calculate lambda also, no problem. Lambda also you can calculate. Okay. So from this beta is pi by 6, 3 comes here, 6 and 10 cube. So 2 pi by lambda, pi by 6, 10 cube. From this you can calculate lambda. So 2 pi cross multiply into 6, divided by pi into, so ultimately you get here 12 into pi gone, 12 into 10 power minus 3. Actually, if you want epsilon r, he has given frequency. Okay. Frequency is epsilon r. Actually, I am thinking to use a simple formula. So one is omega by beta is c by root mu or epsilon r. From that also you can get, because it is dielectric, and you can use this formula. Lambda is equal to omega by beta is equal to lambda naught divided by root mu or epsilon. This is also one formula. Or otherwise directly lambda is equal to lambda naught divided by root mu or epsilon r. Of course this only. So that implies lambda is known, lambda naught is c by f. We can calculate. So here lambda is 12 into 10 to the power minus 3. Lambda naught is c by f. C is 3 into 10 to the power 8 divided by f is given 10 into 10 to the power 9. Then for dielectric medium mu r is 1 epsilon r. Okay. 10 power, this is 10 power 10. It goes 10 power minus 2. 10 power 10. 10 power minus 2. 3 into 10 power minus 2. Then root epsilon r is equal to 3 into 10 power minus 2 divided by 12 into 10 to the power minus 3. So that is nothing but 30 by 12. So this from this you get 3 times 10. 3 times, no? Yeah, 10, 4. 10, 4. That means 2.5 you get. Then epsilon r is equal to, this is root epsilon r. Epsilon r is equal to whole square of that 6.25 you will get. So that is in option D, student. It is option D. Actually, I was telling you this formula is very important. I was telling you, did you remember I kept this in the box actually? I kept two formulas in the box. So many times we are using them. Here, na, omega beta is given and lambda naught is given. You can find epsilon r because for dielectric mu r is 1. And in this case, lambda is given and lambda naught we know because c by f frequency is given. Then for dielectric mu r is 1 epsilon r. So it is given and this is equal to this. I used this one. And in some questions omega beta is given. Anyway, in this question, yeah, beta is also given. Okay. For this with this combination also you can calculate. From this beta you get, substitute beta here, and anyway omega is given. From that also you get same thing only. So this is a simple one, right? So dear students, here there is a print miss actually, a print mistake. Actually this is not omega. This is lambda is equal to 2 pi by beta, na? That is. So this is 2 pi by beta. So beta is equal to 2 pi by lambda, and if it goes here, it comes here. So here I was telling you that if beta is given here and lambda naught c by f, from this also, from these two also you get, or otherwise you calculate lambda. From lambda and lambda naught relation also you get epsilon r. And already I was telling you one more formula, na? Phase velocity is equal to omega by beta is equal to c by root mu r epsilon r. These two formulas, no, I told you one below one. I told you while explaining lossless dielectric. From this formula also you can calculate this one, because omega is 2 pi f. F is 10 power 10 h given. beta we got here, and C is 3 into 10 power 8, mu r is 1, epsilon r value you get same answer from this also you get. That is why these two formulas are very important, students. Okay. Now let us solve these questions. The skin depth in good conductor is 4 micrometer. That means del is given as 4 micrometer is given. At a frequency 200 kilohertz, that means 2 into 10 power 5 hertz it is given. Calculate the velocity of the EM wave in a conductor. Actually, velocity is equal to omega del, student. So 2 into pi into f into del. So 2 into pi, f is 2 into 10 to the power 5. Here skin depth is 4 into 10 power minus 6. So ultimately here you have this is 4 into 4 16, 16 pi, then 10 power minus 6, this is 16 pi 10 to the power minus 1. So this value approximately you get 5 meter per second you get, student. Okay, 5 meter per second, right? Yeah, approximately 5 you get. Now repeat the above for the same material if the frequency is made 4 times the given frequency. Actually, let us say in previous in previous question, frequency f1 we will call that frequency is 2 into 10 power 5 hertz. Now in this question, frequency 2 is equal to 4 times of that frequency, so 4f1. Now repeat the above for the same material. That means here V1 is 5 meter per second at this frequency we got. Now what is V2 we have to calculate, students. Here velocity is equal to omega del. Okay. Now that is equal to omega is 2 pi f. Del is 1 by root pi f mu sigma for the conductor. That means f by root f. Here frequency is changing now, f by root f. Ultimately, for this velocity is proportional to root f. So v2 by v1 is equal to f2 by f1 under root. That means v2 divided by v1 is 5. That is equal to f2 is 4 times f1 divided by f1. So here root 2 root 4 is 2 you get. So v2 is equal to 10 meter per second. So option is B for this. So this is the answer. Some students simply directly they take V is proportional to F. By seeing this now, they take V is proportional to F. That is wrong answer. Here also F is there in that. So this is the answer. Now you see this question. An electromagnetic wave having frequency f0 gets attenuated by a factor of e power minus 2 after propagating a distance d in good conductor. That means he is talking of good conductor. You know that in good conductor E bar is equal to EI0 into e power minus alpha. In the good conductor, alpha is root of pi f mu sigma into z alpha. Z alpha is root pi f mu sigma in good conductor. Then cos of omega t minus beta z. Of course, beta is also root pi f mu sigma only. This is for good conductor. Okay, this is for good conductor. Now what he is saying, when wave travels for a d distance in a good conductor at frequency f0, the EM wave get attenuated by a factor of e power minus 2. Okay, that means here attenuation factor, no student. If you see here, attenuation factor for z distance is equal to, what is the attenuation at z distance? E0 e power minus of root of pi of mu sigma into z divided by initial electric field. Electric field at z distance divided by initial electric field is called as attenuation factor. So this cancel. Ultimately, e power minus of root pi of mu sigma into z is the attenuation factor. Now, this attenuation factor is e power minus of root of pi of mu sigma into z. Now, at f naught frequency and d distance, attenuation factor is equal to e power minus of root of pi f naught mu sigma into, in place of z, d is kept. This is actually formula. Based on formula for a good conductor, this is the attenuation factor. And in the question it is given e power minus 2. So that is equal to e power minus 2. It is in the given data it is. Now compare both of them. So this side minus, and if you compare that one, you get root of pi f naught mu sigma is equal to 2 you get. You got this one. Okay, let us say equation 1. Now, if the signal frequency is now reduced to 0.5 f naught, and after traveling the same distance d in the same conductor, the signal will get attenuated by a factor of. Now, at f naught by 2, so 0.5 f naught means at f naught by 2, frequency for d distance, attenuation factor is equal to e power minus of root of pi. Now frequency has become f naught by 2 and mu sigma, same medium means same mu, same sigma will be there, and for distance d as given. Now that is equal to e power minus of root of pi f naught mu sigma divided by root 2 into d. So from equation 1, I will do one thing. I will put this equation 2. So put equation 1 in 2, then attenuation factor this is, okay. Then attenuation factor is equal to e power minus of this root pi f naught mu sigma into d. Students, here d is missing, okay, into d. This one e minus, then root pi f naught mu sigma into d is equal to 2 actually. So this numerator quantity becomes 2 and divided by root 2, right? That is equal to e power minus root 2. So that is in option C actually, right? Okay, dear students, now see this question. The intrinsic impedance of a copper at high frequency is, actually already we have studied this. Copper is very good conductor. If you see na, copper has a sigma 5.8 into 10 to the power 7 mho per meter. Anyway, for copper approximately epsilon is equal to epsilon naught only, that is 1 by 36 pi 10 to the power minus 9. Okay. Now at high frequency, you calculate omega by sigma by omega epsilon, that is epsilon naught. Sigma is actually 5.8 into 10 to the power 7. Omega is 2 pi f. Then this is epsilon naught is 1 by 36 pi into 10 to the power minus 9. Now that is equal to, here 5.8, this is to cancel 18, then 10 power 7, 10 power 9 goes numerator, 10 to the power 16 divided by frequency. Have you seen, student, this factor, even though if high frequency is very high, here you see very big value is there in numerator. Even very high frequency, denominator cannot be more than this. So definitely this is much greater than 1. Already we have solved for a good conductor, sigma by omega epsilon is very high, and for this case we have solved that intrinsic impedance is equal to this intrinsic impedance is equal to 1 by sigma del plus j1 by sigma del we have solved, right? Anyway, direct formula also you can substitute. We have solved this one for a very good conductor. For good conductor, because copper is very good conductor, students. This we solved in the notebook actually. So intrinsic impedance is complex with inductive component, means plus is there. Plus is there means that is inductive component actually. So this is the answer D. Now for the intrinsic impedance of copper at the 3 GHz with parameters mu given, epsilon given, sigma given for copper, it is better these type of questions you solve by directly substituting in the impedance formula you know already. So here everything is given. Eta is equal to j omega mu divided by sigma plus j omega epsilon, and everything is given, you can substitute directly. So this is equal to j into 2 pi, f is 3 into giga means 9, and mu is given as mu naught only 4 pi into 10 to the power minus 7 divided by sigma is 5.8 into 10 to the power 7 plus j 2 pi, f is 3 GHz, 3 into 10 power 9, so 2 pi f. Epsilon is given here 1 by 36 pi 10 to the power minus 9. So this value you get, if you calculate now, students, you get this one 0.02 e power j 5 by 4 you get. Okay. Now you see this question, which one of the following gives the values of the attenuation constant, constant, that means attenuation factor, that is alpha, and phase shift constant beta for a wave propagated in good dielectric having actually good dielectric is not a perfect dielectric. Perfect dielectric means sigma 0. Good dielectric means OK type dielectric. This is also called lossy dielectric. Already we have derived this by taking a sigma by omega epsilon much less than 1. We have derived this already. This is case 2 actually. For this, alpha is 1 by 2 sigma root mu by epsilon. This is standard question. Beta is omega root mu epsilon. So this is the answer for this. In the options, it is in option A actually. This is standard question. Now the depth of penetration of a wave in a lossy dielectric increases with increasing. So this is again case 2 in the notebook. So for lossy dielectric, that alpha is equal to 1 by 2 sigma root mu by epsilon. For any medium, skin depth or otherwise depth of penetration, del is defined as 1 by alpha. So del is 1 by alpha means 1 by 2 sigma root, that implies skin depth is equal to 2 times root epsilon divided by sigma root mu. You can see here how to increase skin depth. Then conductivity, increasing conductivity, no. Increasing permeability, no. Increasing wavelength, nothing relation. Increasing permittivity, yes. If you increase the permittivity, then this skin depth also increases. So this is the answer. Permittivity increased. Okay. So dear students, now let us see in regular workbook question number 24. and in GATE workbook, it is question number 18, that is chapter 3. Given EM wave in a lossless material E of x comma t is equal to 25 sine 10 power 8 by 5t minus z ay cap. The time average pointing vector is, time average pointing vector is, actually here medium is not given, but lossless medium is given. Lossless means sigma is equal to 0, that means alpha 0. Anyway, here e power minus alpha j term is not there, no issue. Now, actually, for this medium, epsilon r value is not given. Of course, mu r is not given means you have to take 1, but epsilon r value is not given, so you cannot take 1. For that, omega and beta is given. So here beside time, omega is given. Omega is 10 power 8 divided by 5, and beside distance, beta is 1 actually. Beside z distance, na, beta is 1. So I told you take this formula Vp is equal to omega by beta is equal to C by root mu r epsilon r, and here omega is given 10 power 8 divided by 5, beta is 1. So this is 3 into 10 to the power 8 divided by mu r is 1 if not given, then root epsilon r. From this root epsilon r is equal to 3 into 5 into 10 to the power 8 divided by 10 power 8. So root epsilon r is equal to 15 you get. Okay. Now, if sigma 0, actually eta is equal to what? You know already. Once again, I am making you recall. So if sigma 0, lossless medium, na, because given lossless. So then eta is equal to root mu by epsilon. That means root mu naught epsilon naught root mu r epsilon r. So eta is equal to 120 pi. So this is mu r is 1, epsilon r is required. So epsilon r already you found root epsilon r. Okay. So now in this case eta is equal to 120 pi divided by root epsilon r, that is actually 15. Now time average pointing vector is equal to half into electric field initial value whole square divided by modulus of eta. This is modulus of eta. Now a p cap, that means unit vector in power flow direction. So that is equal to half into electric field initial value is 25, it is given. So 25 whole square divided by, this is 120 pi divided by 15, and AP wave is going in plus z direction, power also goes in plus z direction. So this is the answer, and you may get after calculation 12.433 watt per meter square. You do that calculation. So this is the answer. Okay, watt per meter square, 12.433 watt per meter square you get. Okay. Now this is question number 25 in regular book. In GATE workbook, this is question number 19 actually. I am writing all the questions now. So all are conceptual questions only, you can't skip any question. Calculate the time average pointing vector of calculate the time average pointing vector of the EM wave in free space. That means air medium is given in free space whose 1 by 1 is given, h bar is equal to 50 sin omega t minus beta z ax cap 150 sin omega t minus beta z ay cap. So second one, h bar is equal to 50 sin omega t minus beta z ax cap 150 cos of omega t minus beta z ax cap. Fifty sin omega t minus beta z ax cap 150 cos omega t minus beta z ay cap. Actually, students, first you take this magnetic field component, x component. Then because of that, for example, answer I am telling you, first case, no? First you take this component. Because of that, what is the average Poynting vector you find? Similarly, you take this component. Because of that average Poynting vector you take. Then total average Poynting vector is sum of them. Because magnetic field x component generates electric field y component and magnetic field x component and electric field y component carry the power in z direction. There is no link between them. Now this is magnetic field y component. This generates electric field x component. So here magnetic field x component generates electric field y component. They carry the power in z direction. And here I am telling you one hint for you. You can see here. For example, electric field has a x component. Then electric field has a y component. What I am telling you is magnetic field also has a x component, okay, and magnetic field has y component. What I am telling you is electric field x component generates magnetic field y component. Similarly, electric field y component generates magnetic field x component. Now, if you see Poynting vector, for example, E of t cross h of t. Okay, see this carefully. Case 1. I am telling you that electric field x component, you take that electric field x component and magnetic field y component. Now that is equal to Ex Hy. Ax cross Ay is actually Az. That means conclusion is in case 1, electric field x component generates magnetic field y component. So that is why you wrote Ex by Hy is equal to eta. Meaning is that electric field x component generates magnetic field y component. Magnetic field y component generates electric field x component. Both of them carry the power in z direction. That is one pair actually. वो एक जोड़ी है. फिर सेकंड जोड़ी क्या है देखेंगे. केस 2. Poynting vector, that means that gives direction of power flow. Case 2. I told you electric field y component in place of E of t cross h of t. In place of electric field, I am taking electric field y component. Then that electric field y component generates magnetic field x component actually. Now from this electric field y component and magnetic field x component, Ay cross Ax is actually minus Az. In this case, maybe electric field y component or maybe magnetic field x component. One of them will have minus sign. Then if one of them will have minus sign, then minus into plus becomes minus. Minus into minus again it becomes plus. Actually into means I am calling product as into. Don't confuse. For example, Ey into Hx means in my language Ey multiplied with Hx. Don't confuse. Okay. So here naturally inside the equation of Ey component, inside the equation of Hx component, in one of them minus sign will be there. They have opposite sign. So because of that opposite sign, here you get minus. This minus multiplied with this minus, again you get plus. Power is carried in plus z direction. One of them will have opposite sign. So here Ey or Hx will have opposite sign inside those equations, because this equation is very big now. For example, Ey is equal to Ea0 into cos or sine. In that minus will be there in the direction. So Ey or Hx will have opposite sign. So product that is Ey, this one, Hx will have minus sign. So if they have this product will have minus sign, minus into minus becomes plus. Okay, so that means okay, anyway you understood now. This have minus sign, minus into minus becomes plus. Now I am telling you, electric field Y component and magnetic field X component, they also carry the power in plus Z direction. So there are two options. This is one pair and this is one pair. Both carry the power in Z direction. For power transfer, one of the pair is sufficient. That is the meaning. Same discussion comes in the rectangular waveguides also, students. So I told you everywhere we take that power is traveling in Z direction. Okay, to travel power in Z direction, either electric field will have X component and magnetic field Y component, or otherwise electric field will have Y component and magnetic field will have X component. So here one of them will have opposite sign. Okay, now you come to this discussion. Here magnetic field X component is there. This magnetic field X component generates here electric field Y component, so that they carry the power in Z direction, because wave is traveling in Z direction. Similarly, here magnetic field has Y component, then it generates electric field X component. They carry the power in Z direction. Similarly, here now conclusion is that here sine signal may be there, cos signal may be there, here X component or Y component, any component. So every component carries the power. So total power carried is power carried by this component plus power carried by this component. That is the answer. That means all of them have same answers. Here also magnetic field has X component that generates electric field Y component. Here also magnetic field has X component. It generates magnetic field. It generates electric field Y component. Both carry the power in Z direction. You can see here minus Z is there. Similarly, this one also. So H bar may have both X components, or otherwise one X and one Y, and maybe sine cos sine cos doesn't matter. All carry the power. So all of them have same answers. Now you have to use the superposition principle. So for above equations, PAVG bar is actually here PAVG bar is equal to students, I am writing the formula here. This is written free space here. That means average pointing vector is equal to half into Ea0 square divided by eta naught for free space. Then wave propagation direction is Z. Otherwise, if you write in terms of H, no, this is Hi0 and eta naught Az you get. Okay. If electric field square comes, denominator is the impedance. If magnetic field square comes, in product term you will have eta naught. So now let us write them. For this, what is the average pointing vector? So it is magnetic field component. So half, you have to use this formula. Half 50 square magnetic field component, no? Then eta naught is 120 pi. Then wave propagation direction is AZ. Then for this component, once again, half into 150 square and eta naught is 120 pi. So this formula I am using, AZ cap. So for all of them, this is the answer, watt per meter square, right? Next question is question number 26 in regular workbook for ECE GATE students, that question number 20. Anyway, I am solving all the questions. So for both students, these questions are useful. Here unnecessarily confused, but procedure is same. Two components are there. So find average Poynting vector due to each component and add them. That is the answer. So analytically, we will talk of polarization after this. Maybe one concept is there. After that, we will talk of polarization. And elliptically, polarized wave traveling in the positive z direction in air medium has x and y components. X and y components. The time average Poynting vector is. So here x component is given as 3 sin omega t minus of beta z volt per meter, and Ey is equal to 6 sin omega t minus beta z plus 75 degrees volt per meter. So dear students, actually in this question two components are given, okay, and this electric field x component generates magnetic field y component, then this pair carry the power in z direction. Similarly, this electric field y component generates magnetic field x component, and so that it carries the power in once again in z direction. So because of this, how much average Poynting vector comes, you calculate, and because of this how much average Poynting vector you get to calculate, then you have to add both of them. Okay, so here the answer is like this: average Poynting vector is equal to half into formula what you use here, half into EI0 square divided by eta. So you see carefully, somewhere here small letters are there, air medium. So eta naught into power flow direction is AZ. Actually, no, dear students, we have studied that. I am writing here complete formula. Wait a minute. Average Poynting vector is equal to half into EI0 square by eta and e power minus alpha z cos of theta eta power flow direction is AZ cap. Now some students confuse, sir, is there any theta eta because 75 degrees is given here? No, dear students. Every student knows, we have studied, go and refer in the notebook, for air medium theta eta is 0. Here for confusion purpose he has given this Ey electric field y component has 75 degrees, that generates magnetic field x component. In that magnetic field x component also, inside cos term you will get 75 again. So that phase difference is 0. Why? Because in air medium we have studied theta eta is 0 actually. So for air medium alpha is also 0, theta eta is also 0. Actually this is the original formula. So modulus of eta. So for air medium, you go and see case 1 in the notebook. For air medium students, alpha 0, so that it is 1, theta eta is equal to 0, cos 0 is 1, and mod eta becomes eta naught 120 pi. Once again I am telling, in a air medium, electric field y component generates magnetic field x component. Inside this sine term or cos term will come. If sine term is there here, here also sine term will come. Here sine of omega t minus beta z plus 75 only comes. So the phase difference once again 0. So that no need to take theta eta, because for air medium that is theta eta is 0 actually. So that cos theta eta is 1. So you have to use average Poynting vector formula for air medium. So dear students, for air PAVG bar, electric field components are given is equal to EI0 square half eta naught, and power flow direction is AZ cap here, right? Now PAVG bar is equal to, due to this term, average Poynting vector is half into 3 square divided by 120 pi Az, plus for this component average Poynting vector is half into 6 square 120 pi Az cap. So ultimately this, if you calculate, you get 59.7 Az cap milliwatt per meter square we get. So the approximate answer in option C it is there. In option C it is given 62.5. Sometimes this is actually, one of the examination is given, sometimes they give small mistakes. You need not to worry about them. Okay students. Now you see the next question, that is the electric field equation is given, magnetic field equation is given. You have to find the time average Poynting vector. Time average Poynting vector. Okay. That is in regular workbook question number 27. In GATE workbook, that is question number 21. Anyway, don't bother about the question numbers. स्टूडेंट्स है वर्कबुक उठा के क्वेश्चन नंबर को ढूंढते रहता है, सॉल्यूशन के ऊपर ध्यान दे देना. एक्चुअली आई एम राइटिंग द क्वेश्चंस ना, नो इश्यू एट ऑल. So here this is I am writing the question here. If electric field AX cap plus JAY cap, while reading the question, while writing the question, you are listening, you must get idea, because while writing question time is there, that is for thinking purpose. The time must be utilized for thinking purpose. So e power j k z, k means beta. In some books beta is used as k, I told you. So beta means phase shift constant, or otherwise the wave number it is called as, minus of j omega t. Okay, you can write them separately. E power jkz multiplied with e power minus j omega t you can write, and h bar is equal to k divided by, that means beta, k by omega mu ay cap jax cap and e power jkz minus j omega t. The time average Poynting vector is, the time average Poynting vector is, I told you, doing calculations in time domain is little difficult. If you do calculation in phasor domain, then you get same answer, but mathematics will be very simple, I told you. So now let us write the average Poynting vector equation given electric field and magnetic field. So average Poynting vector PAVG bar is equal to half into real part into electric field phasor cross product magnetic field phasor, but complex conjugate you have to take. So this is in phasor form ES, and this is in, actually if you remove e power j omega t na, automatically that will be in phasor form. So anyway, I will take here Okay, I will take the complex conjugate of this one. H bar star is equal to K omega. Complex conjugate means if plus j is there, you have to put minus j. If minus j is there, you have to put plus j. So here no j term. Then ay, here plus j is there, minus j you have to put. Okay, plus j is there, minus j you have to put. Then e power, here plus j is there, minus j you have to put. Here minus j is there, so plus j you have to put here. Now this is equal to half into real part into this is that one es bar ax cap plus j ay cap then e power j kz minus j omega t. Okay, I will put like this. Okay, no need to put like this. Why? Because this becomes e power 0 after writing. Keep watching now. Here cross product, this is that one. K divided by omega mu and ay minus jax, then e power minus j kz plus j omega t. So dear students, here what is happening? Cross product is done only for directions. Where are the directions here? So you can see here, these are the directions, these are the directions. That means cross product is done for this one and this one, but not for the terms which doesn't have direction. This doesn't have direction because ax, ay, az not there. This also doesn't have direction. This also doesn't have direction. So this can come out of the cross product. Now this one, if you multiply, you will get in exponential e power 0 you get. E power 0 is 1. So it can come out. You have to take cross for this term and this term only. So I am writing here half, and this can come outside. K by omega mu comes outside. Then real part of you get ax plus jay cross, and this one okay, you write any term, no problem. First you can write x term, doesn't matter, minus j ax cap. So real part means what actually? Real into real, or otherwise imaginary into imaginary, you get real part. So here what you do, you can multiply entire term and you can pull real part, or otherwise when you get real, you multiply real into real, then you get real. Imaginary into imaginary also you get real. So let us do that now. That is equal to half into k by omega mu. So this is real, this is also real. You take cross product, ax cross ay. Here ax cross ay is az. Directly I am taking a real part, students. Real into real, az. Then real into imaginary, you get imaginary. We want real, leave it. Then what is this one? Imaginary multiplied with real, you get once again imaginary, but we want only real. Then this multiplied with this one. J into j, j square. J square is what? Minus 1. Minus into minus plus. So plus ay cross ax. Ay cross ax is minus az. So ultimately you got 0. So this is a vector actually. If scalar becomes 0, you call it as a null. But if vector becomes 0, you call it as a null vector. 0 means null. If vector becomes 0, you have to call it as a null vector. Okay? Null means 0. What is 0? This vector. When vector becomes 0, that is called null vector. So option is A. Okay? Right.